Recovered from a 1st century BC shipwreck, the Antikythera Mechanism is the oldest known geared mechanism in the world, an ancient astronomical computer. For decades, determining exactly how it worked required researchers to look closely at Fragment A, a heavily corroded fused mass of bronze. The standard professional understanding of the device was established in 1974 by science historian Derek J. de Solla Price in his foundational monograph Gears from the Greeks. This schematic outlines Price's most famous assertion. The device utilized a sophisticated epicyclical differential gear positioned centrally. He argued this assembly calculated the lunar synodic month, transmitting data down a gear train to display the moon's phase on a back dial. There is a problem with this historical reconstruction. The brilliantly complex differential gear featured in Price's model does not physically exist, a discovery that alters our entire understanding of what the machine was built to do. This diagram illustrates Price's differential gear requiring two inputs. One turns at the rate of a tropical year, the other at a tropical month, spinning in opposite directions. Their interaction forces the platform to turn at exactly half the difference of the two speeds. The resulting mathematical output of this calculation is exactly 1/2 synodic months. To make this display correctly, Price's model uses a fixed-axis train below the platform to double the output rate, ultimately driving a pointer on the lower back dial at the speed of 1 synodic month. Price believed the ancient designer used this method to physically model the metonic ratio, the astronomical principle that exactly 235 synodic months fit into 19 years. While mathematically elegant on paper, this theoretical model creates massive, unresolvable friction when applied to real-world physical engineering. The first major engineering flaw in Price's model is power distribution. The entire system is driven from the slow-moving end of the gear train. Pushing power backward through this diagram creates a branched step-up train, demanding mechanical velocity ratios of roughly 12.4 to 1 and 13.4 to 1. When you force a severe step-up ratio through primitive, roughly triangular gear teeth, the heavy load required to turn a differential creates catastrophic friction. Modern horologists and model makers consistently failed to make Price's exact arrangement run smoothly without secretly upgrading the historical specifications. An ancient engineer could have easily achieved a synodic month output using a simple, smooth-running fixed-axis train directly from the front dial. The presence of an overly complex, friction-heavy design suggests a flaw in the modern reconstruction rather than a deliberate choice by the original builder. To find where Price went wrong, researchers Wright and Bromley used new X-ray tomography to audit the actual physical bronze fragments of the mechanism. Look at this critical junction in Price's schematic. His entire differential relies on a direct physical engagement between gear D2 and gear B4. The X-ray scans proved that wheel D2 does not touch wheel B4 at all. X-rays revealed an unmapped path. Large wheel D2 actually engages a separate, unnoticed gear, E7. E7 is mounted coaxially with E6, which engages B4. This schematic shows the mechanical consequence of discovering these intermediate gears. They sit between the primary wheels, functioning entirely as idle wheels. Adding an idle wheel into a gear train reverses the direction of rotation. Wheels B1 and B4 now rotate in the same sense, not opposite senses. This single physical fact instantly breaks the opposite input physics required to run Price's differential gear. By mapping the actual physical gears, the foundational premise of the 1974 reconstruction falls apart. The evidence against Price's model compounds when we audit the fixed-axis gear train leading from the epicyclic platform down to the lower back dial. To make his output equal exactly 1 synodic month, Price needed a perfect 2-to-1 velocity ratio in this specific gear sequence. To get it, he altered the physical couth counts of wheels F1 and G2 in his diagrams to artificially force the math. This table compares Price's idealized numbers with verified tomographic counts. The physical artifact actually holds 192, 54, 30, and 54 teeth. The true velocity ratio resolves to 1.975. A pointer driven by this train would quickly drift out of sync with the moon. The final X-ray discovery is located at the center of the mechanism. Wheel E1 is just a toothless button, and wheel B3 simply does not exist. Without those wheels, the epicyclic assembly only has one input. The central arbor was fixed rigidly to the base plate. The differential gear was a modern hallucination. The Antikythera mechanism relies entirely on a standard gear train with one input and one output. If the central cluster is not calculating a lunar calendar using a differential gear, what is its actual function? Relying strictly on the new physical data, M.T. Wright developed an updated model, a sophisticated mechanical planetarium displayed directly on the front dial. In this architecture, the fixed arbor epicyclic clusters control individual pointers, tracking the motions of the Sun, the Moon, and the 5 planets known in antiquity. The staggered epicyclic arrangement allows the machine to physically model the variable, anomalous motions of these planetary bodies, matching the astronomical theories of Hipparchus. This planetarium function aligns perfectly with surviving historical reports of geared instruments, written in the 1st century BC. Price's differential was mathematically clean but physically impossible. Wright's model works because it accepts the gritty, uneven realities of the surviving bronze. Correcting this gear train resets our understanding of Hellenistic technology. It proves that ancient engineers achieved complex variable motion without the specific differential architecture invented centuries later. True engineering history requires strict adherence to physical data, measuring the metal tooth by tooth, rather than forcing a historical artifact to fit our modern mathematical assumptions.